pretty bad when it won't even grow weeds. Over the years, we see more and more frequent high tides. We've always had like at least annual or biannual high tides. Now they're every year, sometimes 2 and 3 times a year.
I'm Becky Apanchin-Neal, and I'm an associate professor in the Ag and Resource Economics department. So the goal of this project is to try to better understand the spatial distribution of salinity impacts on the eastern shore of the Chesapeake Bay, so Maryland's eastern shore. And there historically has not been any sorts of maps or data showing that distribution, and so we have been going in and actually taking soil cores and mapping out the salinity.
My name's Rick Abend. The name of our farm is Abendhofen Farm. It's German for evening haven. It's my retirement place. I bought this parcel here in 1972, primarily as a place to come hunting. And it was all woodland, and it remains as such. Leasing about 32 acres to a local farmer, and then we have 14 acres in the Conservation Reserve Program, which we're basically using for wildlife habitat. The crop fields out there, they're just getting harder and harder to produce anything.
The saltwater intrusion is the landward movement of seawater that ends up causing salinization of these soils. And for example, in agricultural lands, most of the crops that we grow will not grow when those soils are affected by salinity. So you have these decreasing yields. There's this kind of elevation threshold where you're seeing a lot of salinization below that level and not above that level. And that really helped inform our study methods for this, in that we wanted to be able to span that gradient to try to understand, is that a threshold? How does salinity vary across this elevational gradient? And the idea is that it's tied to sea level rise. And so if you think about potential overwash of saline waters, that's one of the mechanisms by which these soils can be salinized.
One day, it's not going to be this generation, but it's going to probably turn into a ghost forest, which the biggest one I know of is just 2 miles down the road from us. And it's kind of creeping this way.
We had a set of fields that we were able to access through our various different partners, so working with different land conservation NGOs and NRCS and Maryland Department of Agriculture to try to identify landowners who would be willing to let us on their land, and then using actual elevation maps. And so where we are essentially targeting soil samples within each of the different elevation bands so that we could have this representation across this gradient. And so then we can use those inputs to analyze the salt impacts.
We're getting some saltwater intrusion and phragmitis creeping into our woodland. And what generally happens when you get a situation like that is the next time this timber is cut, phragmitis is just going to take over.
Most importantly is that by being able to make maps that help us predict how salinization is likely to unfold over the future, it provides information both for, say, farmers and landowners, state planners, NGOs, all of those different individuals who will be able to use that in terms of trying to help identify what kinds of transitions can be made in these landscapes, how people may need to adapt, where we can target resources and information. One of the most exciting things that we've seen with these results is that we are able to very much identify a statistical relationship between elevation and sea levels over time and the salinity impacts. And I think that the exciting part about that is that it's going to enable us to create maps, essentially risk maps of how we think salinization is likely to unfold over time. So if we link that to sea level rise data, it allows us to think about not just what's going on right now, but also what our predictions are in the future, which then can feed into decisions being made across different types of decision makers. Being able to provide some information about, well, what kinds of crops are likely to grow better in these regions? What are these transitions or adaptations you can do in the near term? But then, and it's really unfortunate, but in many cases, a lot of these parcels are going to be underwater, or they're not going to be able to grow things. Knowing that that's going to happen can help in the sort of time horizon, maybe where that happens. Maybe it can help identify different resources such as conservation easements or other types of programs that can provide some financial and technical assistance with working through that transition. Depending upon where you're located on the landscape, you're going to be affected by sea level rise near or later into the future.
So it's a losing battle. I mean, we're trying to save as much time as we can, but I don't think we're going to win.